We'll start with the 6th lesson, atomic physics. So today we know the structure of atom very well, isn't it? Take your up note. Okay, listen. Is it possible air is a very good conductor or a poor conductor of electricity? Air is a poor conductor or a good conductor of electricity? At normal atmospheric pressure, air is a poor conductor of electricity, isn't it? What that mean? I can't able to get or availability of free electrons is not there in a air or gases. Air is nothing but a mixture of gases. So availability of free electrons is not there in a air or gas. So how I can conduct electricity in gas, in a gas or air? Is it possible to conduct electricity? First question. This was a question raised by the scientist. Is it possible to conduct electricity in air? Is it possible? Then why I have to do that? Second question is, it's my question, why I have to conduct electricity through gases? What is the use of it? Is it have any practical use of doing that? Say yes or no. Irukka illaya? Idella padikkiradhukkaga edha practical use irukka? Say just yes or no. Definitely there is use, isn't it? That's why we are going to deal with that. So is it possible means yes, is it possible to produce charged particles or to charge or to pass electricity in a gas? How it is possible? What are the different ways of producing electricity or charging or passing the electrons or passing the charges in the air? How it is possible? One way, I can reduce the pressure, by that way I can produce charged particles. Or passing a beam of X-rays also I can produce the charged particles in a air or gas. There are two ways. First we will see how to produce these charged particles in a gas, that we call it as the discharge of electricity. Is it possible? First person did that with a very simple experiment. Clear? And the arrangement pair in already you have come across all this. Discharge tube. Can you remember that? What is meant by discharge tube? I can able to produce charged particles under very low pressure in a gas. So discharge tube is nothing but an arrangement. It is just a glass tube of length 50 centimeter. What is the length of this glass tube? It is 50 centimeter and its width will be 4 centimeter. Clear? This is the arrangement, just a simple arrangement to produce or to pass electricity through gases. These two are your electrodes. One is the cathode and the other one is anode. This one is connected to a high induction coil. This one is negative, this one is positive. Can you tell what is this electrode now? Is it positive or negative? It is connected to the negative terminal of this induction coil. Then this one is anode or a cathode? Cathode. This one is anode. Inside this glass tube, we are enclosing a gas. I have a vacuum pump here. Here I have a vacuum pump and a low pressure gauge. This side tube is connected to a vacuum pump to produce a very low pressure inside the gas. Here the side tube is connected to a vacuum pump and a low pressure case. We will see step by step what happens at different pressures, what are the changes occurring in the discharge tube. What for we are doing this experiment? To pass electricity. Is it possible to pass electricity through gases? What is the use of it? By knowing this only, scientists came to know about the structure of the atoms. Scientists came to know about the structure of the atoms. For example, this is a பொருள் இல்லையா? இதுல என்ன இருக்கு அப்படினு தெரிஞ்சுக்கணும் என்ன பண்ணுவ? உடைச்சி பாப்பீங்களா இல்லையா? Like this only we are going to do in a gas. That's all. Simple thing. ஒரு பொருளுக்குள்ள என்ன இருக்குன்னு தெரிஞ்சுக்கிறதுக்காக என்ன அதனுடைய ஸ்மால் கான்ஸ்டிட்யூயன்ட் என்னன்னு தெரிஞ்சுக்கணுமா இல்லையா? பேசிக் எது, ஃபண்டமெண்டல் எதுன்னு தெரிஞ்சுக்கணும். அதே மாதிரி இங்க வந்து ஒரு ஆட்டம்ன்றது தான் ஃபண்டமெண்டல் பார்ட்டிகல் ஆஃப் ஆல் தி எலிமெண்ட்ஸ். This was the who said this first? யார் இத first சொன்னது? All elements contains fundamental particles called atom. Atom cannot be subdivided. சொன்னது யார் first? Dalton. Dalton was the first person to explain this, isn't it? இதே மாதிரி தான் நம்ம இப்ப படிக்க போறோம். இன்னும் further பார்க்க போறோம் ஆட்டமுக்குள்ள என்ன இருக்கு. By this only we came to the conclusion here. At each temperature, ஒரு வேல்யூவா பார்த்தாங்க. When the pressure of the gas inside this discharge tube is about 110 millimeter of mercury. எவ்வளவு இருக்குமா? First, he didn't see any change. எந்த சேஞ்சுமே தெரியல. இங்க அந்த inside the discharge tube குள்ள. Further, he reduced the pressure of the gas inside the discharge tube to about 100 millimeter of mercury. எவ்வளவு இருக்கு இப்போ? 100 millimeter. At this low pressure, he can able to see some changes inside the discharge tube. என்ன கவனிச்சானா, he can see some irregular streaks of light. Irregular streaks of light னா தெரியுமா? அந்த மின்னல் வரும்போது இப்படி இப்படி மின்னும் பாத்திருக்கீங்களா? அந்த மாதிரி இதுக்குள்ளேயே ஒரு irregular streaks of light தெரிஞ்சது. இதுக்குள்ள the discharge tube குள்ள at this low pressure. What is this value? 100 millimeter of mercury இருக்கும்போது discharge tube குள்ள ஒரு irregular streaks of light followed by crackling sound. Tap tap on வெடிக்கும்ல அந்த மாதிரி ஒரு sound கேட்டது. So what that mean? Discharge has taken place. Discharge ஆக ஸ்டார்ட் ஆயிருக்கு. Discharge has just started up at this temperature, at this pressure. So discharge took place at this pressure. Discharge start ஆயிருக்கு. Now further he reduced. என்ன பண்ணாரு அவரு? Further he reduced the pressure value. When the pressure of the gas inside the discharge tube is about 10 millimeter of mercury, in the low level இருக்கும்போது what happens? He can see this irregular streaks just extended from anode to cathode. முதல்ல irregular தெரிஞ்சது இல்லையா அந்த streaks of light, இந்த pressure valueல என்ன ஆச்சு? It has extended from anode to cathode. Extend ஆக ஆரம்பிச்சு ஃபுல்லா ஒரு luminous stream மாதிரி தெரிய ஆரம்பிச்சு. எப்ப? At this. Since it has extended from anode to cathode, he called this column as positive column. He called this as positive column. So positive column எந்த pressureல produce ஆச்சுன்னு they may ask you in 1 mark. அப்பப்ப சொல்லும்போது bookல underline பண்ணிட்டே வாங்க. புரியுதா? So positive column எந்த pressureல produce ஆச்சுன்னா at a pressure of about 10 millimeter of mercury. Clear? Then further he reduced. இன்னும் reduce பண்ணி பார்க்கலாம். What happens? At a pressure of about 0.01 millimeter of mercury, he can see no light at all. ஒரு luminous stream தெரிஞ்சது இல்லையா 10 millimeterல. Further reduce பண்ணும்போது he can see only a dark space inside the discharge tube. என்ன தெரிஞ்சது அவருக்கு? ஒரு dark space enclosed ஃபுல்லா தெரிஞ்சது. இந்த dark spaceல the walls of the glass tube started fluorescence. ஒரு fluorescence effect தெரிய ஆரம்பிச்சது at this pressure of 0.01 millimeter of mercury. Fluorescence na enna? What is going to be fluorescence? The glowing or glowing effect. அப்படி glow ஆக ஆரம்பிச்சது எது? Not inside. The walls of the glass tube started glowing. That effect we call it as a fluorescence effect with the green color light or green light. உன்னுடைய ரீடர்ல first pageலயே frontல போட்டுருப்பாங்க பாரு ஒரு டயக்ராம். first page அந்த frontலயே இருக்கா? green colorல தெரியுது பாத்தியா? அது என்னது? It is nothing but the fluorescence effect. Yeah? So what is the cause of this fluorescence effect? Some rays which are emanating, which are produced from this cathode. Cathode lende vara oru sila rays. I don't know the properties of the rays. Those rays are responsible for this fluorescence effect. The fluorescence effect edanala kadakidhu? Some invisible rays are coming out or emanating out of the cathode. Those rays are producing this fluorescence effect. Clear? This is the final stage of this discharge tube. இதுதான் அவருடைய final stage கழிச்சது. So where he can find those invisible rays which are producing fluorescence effect at a pressure of about 0.01 millimeter of mercury. These invisible rays he called it as the cathode rays. He called it as cathode rays. So cathode rays எப்ப produce ஆச்சு? At a pressure of about 0.01 millimeter of mercury. So in the 4 stages மறப்பீங்களா? First one 110 millimeter. Discharge happen? No discharge. எழுதிக்கோ வேணாம். Next 100 millimeter of mercury. Discharge started. Then 10 millimeter of mercury என்ன தெரிஞ்சது? Positive column. Further 10 அப்படியே invert பண்ணு. 10 திருப்பி போட்டா எப்படி வருது? 0.01 முன்னாடி ஒரு பாயிண்ட் வச்சிரு. Like this you remember. 0.01 millimeter of mercury இருக்கும்போது ஒரு Crookes dark space. There I can see the fluorescent effect. This fluorescence effect was because of the rays which are emanating out of the cathode, those rays he called it as the cathode rays. Then he studied about the properties of these rays. The properties தெரிஞ்சாதானே I can know about the rays and I can use it for my purpose. Clear? Then these cathode rays traveled in a straight line path. எப்படி travel ஆச்சு இந்த cathode rays? Straight line travel ஆச்சு. அப்ப in its path if I have electric and magnetic field, அதுக்கு சார்ஜ் இல்லன்னா என்ன ஆயிருக்கும்? ஸ்ட்ரைட்டா travel ஆகி போயிட்டே இருக்கும். electric field magnetic field வெச்சோனா அதோட பாத்ல ஸ்ட்ரைட்டா travel. But when electric and magnetic field is applied in its path, he can notice there is a deflection in its path. Based on the deflection, based on the direction of the deflection, he came to the conclusion that these rays are having negative charge. The rays can charge irundhathu negative charge. That is why he called this as electrons. These are nothing but electrons pair vechal. Cathode rays na enna charge pa? Negative charge. Those are nothing but the electrons, which are the fundamental particles of an atom. So they travel in straight line. They have travel in straight line, they will be having momentum and energy. They will affect the photographic plate. They can produce, they can ionize the gas through which they pass. If I see the velocity of this cathode rays, they will be 1/10th of the velocity of the light. எப்படி இருக்கும் அதோட velocity? Cathode rays ஓட velocity 1/10th of the velocity of light. How much is the velocity of light? C value எவ்வளோ? 3 into 10 power 8 meter per second. So all these properties he has studied. They can produce fluorescence effect. இதெல்லாம் properties படிச்சார். Then another scientist came. He just took all those experiments in the results எல்லாம் வச்சிட்டு again he did a small modification in the discharge tube and he found out one more change in the discharge. In the effect, in the conclusion la ஒரு சின்ன change கிடைச்சது. Goldstein என்ற ஒரு scientist same experiment he did with a small change. இந்த cathode anode இருக்கும்போது behind the cathode he kept the fluorescence screen, same arrangement. Here I have the anode, here I have a cathode, but the cathode shape will be in the form of ஒரு diskல நிறைய holes போட்டா எப்படி இருக்கும்? Minute, clear? அந்த மாதிரி drill பண்ணிட்டார். ஒரு cathode oval shapeல எடுத்துக்கிட்டு he drilled it. That we call it as a perforated cathode. That we call it as a perforated cathode. Behind the cathode he kept a screen. இங்க என்ன வச்சிருந்தாரு? ஒரு fluorescence screen இருக்கு. There only I can see the scintillations or the effects what we are going to produce here. Now, இந்த cathode நிறைய holes இருந்ததால at a pressure of about 1 millimeter of mercury நமக்கு எப்போ வந்து cathode rays கிடைச்சது? At a pressure of about 0.01, 1 விட கம்மி. In between la 1 millimeter of mercury pressure இருக்கும்போது what happens? You can see some of the rays which are coming from the anode la இருந்து cathode க்கு போயிட்டு they just passed from the holes. எப்படி போச்சு? அந்த cathode ல holes இருக்கு இல்லையா, அந்த holes ல pass ஆகி they came behind, they traveled behind the cathode. அப்ப என்ன ஆகுது? எதனால அந்த cathode நோக்கி வருது? What charge it will be having? cathode க்கு என்ன charge? Negative charge. அப்ப negative வந்து எதை attract பண்ணும்? Positive charge. These rays which are emanating from the anode, they just passed through the cathode and they hit the fluorescence screen. Since these rays are passing towards the cathode, they will be having positive charge. அதனால அதுக்கு positive rays ன்னு பேர் வச்சார். என்ன பேர் வச்சாரு? Positive rays. Depending upon the charge. Then they are just coming out of this perforated cathode. Holes வந்து வெளியே வரதால canal rays. What is the other name he gave for it? Canal rays. So canal rays உடைய charge பார்த்தா it will be having a positive charge. How he came about that? How he came to know about that these rays are having positive charge? எப்படி தெரிஞ்சது அவருக்கு? Same thing. How I can know about the charge of any rays? In its path, what I will do? I will apply electric and magnetic fields. Depending upon the direction of the deflection of the rays, இதனோட இந்த canal rays உடைய direction பார்த்தா it will be just opposite to the deflection of the cathode rays. Cathode rays எப்படி deflect ஆச்சோ அதுக்கு opposite direction இது deflect ஆச்சு. இது canal rays. By this I can come to the conclusion these are having positive charge. இதுக்கு negative தெரிஞ்சிருச்சு. அப்ப இதுக்கு என்ன இருக்கும்? Positive charge. Yeah, he named this as the positive rays or canal rays. Now I can see within a gas, இதெல்லாம் gasக்குள்ள என்னென்ன இருக்குன்னு தெரியுது. So two charges கண்டுபிடிச்சிட்டோம். One is a negative charge, the other one is a positive charge. So positive charge இருக்கு, negative charge இருக்கு. தெரிஞ்சது. Then they didn't give the structure of the atom. Based on these details only, they just found how to give the shape for the atom. ஒரு ஆட்டத்துக்கு எப்படி shape கொடுக்கலாம். Then the Rutherford experiment, radioactivity தெரிஞ்சது இல்லையா? What is radioactivity? The spontaneous emission of alpha, beta and gamma. இப்போ electrons கண்டுபிடிச்சிரோம். Rutherford experiment he found out what is meant by natural radioactivity. The radioactivity electron discover பண்ண பிறகுதான் இன்னும் இன்ட்ரெஸ்ட் அதிகமாச்சு how to know about the structure of the atom. Atom உடைய ஸ்ட்ரக்சர் எப்படி இருக்கும் அந்த இன்ட்ரெஸ்ட் நிறைய அதிகமாச்சு சயின்டிஸ்ட்க்கு டு கண்டுபிடிக்கிறதுக்கு. இந்த இன்வென்ஷனுக்கு அப்புறமா தான் இதுக்கு அப்புறமா radioactivity கண்டுபிடிச்சிட்டு திரும்ப எலக்ட்ரான் யார் கண்டுபிடிச்சது? Electron was discovered by J.J. Thomson. X-rays. How an X-ray is produced? William Röntgen. William Röntgen discovered X-rays. How X-rays are produced? Electrons கண்டுபிடிச்சது J.J. Thomson. இது சொல்லிட்டு half of the answer I told you. How X-rays are produced? When fast moving electrons are suddenly stopped by an element of high atomic weight, X-rays are produced. படிச்சிருக்கீங்களா இல்லையா? Coolidge tube. Coolidge tube நால என்ன ஞாபகம் வரணும்? X-rays. எப்படி X-rays produce பண்றோம்? Fast moving electrons are going to stop it suddenly by a element having high atomic weight. ஒரு மெட்டல் அதுக்கு high atomic weight இருக்கும். இதனால அந்த melting point ஹையா இருக்கும். அத பார்த்தா withstand பண்ண அந்த high temperature. Then it is kept at an angle of 45 degree. X-rays are produced. So X-rays யார் produce பண்ணது? Electrons? J.J. Thomson. So one more important thing, now we will see how to find out the specific charge of an electron. Specific charge. Specific charge na enna artham? Specific and the word meaning என்னமா? Charge of an electron தெரியும். Specific ஒரு யூனிட் மாஸ் ஒரு பர்టిక్యులர் ஏரியால ஒரு யூனிட் மாஸ்க்கு இந்த சார்ஜ் எவ்வளவு இருக்கும்? Clear? Now we are going to see what is the specific charge of an electron. Specific charge means charge per unit mass. What we call specific charge? Charge per unit mass of an electron. Same here. I'll have a discharge tube. Now close your readers. Please take your rough note and just follow this what I'm telling. Here I have a cathode C. It is just heated to a high temperature. When a cathode is heated, it will start eject electrons. So this is negative charge. Here I have two discs. D1 and D2. It's a very narrow place so that the electrons which are ejected from the cathode are made to flow like a pencil of rays. Fine pencil of rays are follow pannum. Then here this one will be positive charge. Here in this path I have two metal plates P1 and P2 of length L. What is the length of each plate? Let it be L. Here only I am going to apply electric and magnetic fields perpendicular to each other. இந்த ரெண்டு metal plates க்கு என்ன கொடுக்க போறோம்? Electric and magnetic field perpendicular to each other. At this other end I will be having a fluorescent screen on which I am going to see the scintillations or the effects what we are going to see. To begin with, I produce electrons. Electrons are nothing but cathode rays. Here I have two anodes D1 and D2. It's a narrow place here. It is a very narrow place so that the cathode, the rays are made to flow or pass like a fine pencil of rays. Here they will pass. Initially if there is no electric and magnetic fields, what they will do? They will travel straight and they will hit the fluorescent screen at this point. Let this point be Q1. What is this here? Q1. What is this point Q1? At that point only I am getting the scintillation effect. Now I am going to apply the electric field. What happens if I apply the electric field? So let this be positive charge, let this be negative charge. Here what are the rays in a rays in the cathode rays? Electrons are flow agudhu. See the charge given to these two metal plates. This is negative kuduthirukkom, idukku positive charge kuduthirukkom. Now when the electric field is applied, what happens to the electrons? Will they flow in the straight line path and go and hit the same place at Q1? என்ன ஆகும்? அது டிஃப்ளெக்ட் ஆகும். எந்த பிளேட்டை நோக்கி டிஃப்ளெக்ட் ஆகும்? P2 ஆ P1 ஆ? எலக்ட்ரான்ஸ்க்கு நெகட்டிவ் சார்ஜ். அப்ப இந்த பிளேட்டுக்கு P2 இருக்கும்போது it will be deflected, it will be attracted towards the positive plate, isn't it? இதுதான் positive plate. So it will be deflected. எப்ப அது இது வரைக்கும் ஸ்ட்ரெயிட் லைனா வரும்? இந்த மெட்டல் பிளேட்டுக்குள்ள என்டர் ஆகும்போது இந்த ஏரியால தான் எலக்ட்ரிக் ஃபீல்ட் கொடுத்திருக்கும். I just apply the electric field within the metal plates only. So when they enter into the metal plates, அதோட velocity என்ன ஆகும்? Change ஆகும். Up to thus it will move with a constant velocity. Say ஒரே velocity ஓட மூவ் ஆயிட்டே வரும். இங்க electric field magnetic field apply பண்ணிருக்கிறதால when they deflect its velocity changes. Can you understand? So they will be deflected from its path and they will go and hit the fluorescence field at some other point. Let that be Q2. What is this Q2? The deflection produced because of the electric field applied. Now I will find out. Let E be the electric field intensity. What you are going to apply? Electric field. Can you tell me what is the force due to this electric field? Electric field formula enna? E equal to F by Q. Here what is Q? Here what are the charges here? Electrons. Can I write Fe in the place of Q? E, because I am using here electrons. Electron charge E done. F by E. What is F from here? E is called capital letter E na electric field strength or intensity. So this is the force experienced by the electrons when an electric field is applied. Now idukku perpendicular I am applying a magnetic field. What I am going to do? I am going to switch on a magnetic field perpendicular to this electric field, so that I have to get again the deflection at the same point Q1. எங்க வரணும் எனக்கு அந்த பாயிண்ட் Q2 க்கு deviate ஆகிருக்கு இல்லையா, Q1 ல இருந்து Q2 க்கு. Now you apply a magnetic field such that the force due to the magnetic field should nullify the force developed by the electric field. நீ எலக்ட்ரிக் ஃபீல்டால கொடுத்த ஃபோர்ஸ இது நல்லிஃபை பண்ணணும். எது? the magnetic field ala nee kudukra force. So you apply a magnetic field perpendicular to this place such that this point Q2 again goes to the same initial point Q1. adukku evlo kudukona appa evlo force kuduthirukku electric field ala same amount of force kudutha enna agum, it will be nullified and I can get back the same point Q1. So can you say what is the force due to the magnetic field? inge third lesson enna padichirukka? Force yes say force due to a charged particle. BQV, correct. நீ சொல்றது எதுக்கு? கண்டக்டருக்கு நீ சொல்றது. So F equal to force due to the magnetic field என்னமா? F equal to BQV, magnetic Lorentz force ல படிச்சிருக்கீங்களா? ஞாபகம் இருக்கா இல்லையா? When a charged particle moves in a uniform magnetic field, it will experience a force that we call it as the magnetic Lorentz force. Third lesson ல படிச்சிருக்கீங்க, recall பண்ணி பாருங்க. Here BQ, Q into the charge of the electron. Can I write E? If I get the same point Q1 again, what that means? The force due to the electric field will be equal to the force due to the magnetic field. Can I equate these two at this point? So, if I equate EE equal to BEV, EE gets cancelled. What is V here? V. Velocity of the electrons. So, what is V now? E by B. So we have calculated what is the velocity of the electrons flowing here. It is nothing but the ratio of the electric field and the magnetic field. Now again you switch off. Now I given the magnetic field. Switch off the magnetic field. What happens if I switch off the magnetic field? திரும்ப எங்க வருது? Q2 க்கு வந்துருமா? First electric field கொடுத்ததால it came here. Q1 ல இருந்து இந்த பாயிண்ட் எங்க வந்திருக்கு? Q2. Now same amount of force கொடுத்தேன் using magnetic field, I got that Q2 again. Why I am doing this? To find out the velocity of the electrons. Now you switch off the magnetic field, where I will be getting the point again in Q2. To draw this diagram neatly, using this I am going to find out what is the charge per unit mass. Specific charge என்னன்னு கண்டுபிடிக்க போறோம். Let this be the two metal plates P1 and P2. இந்த electrons இங்க வர வரைக்கும் அதுக்கு same velocity இருக்குமா? This is the place where they are going to enter into the electric field and the magnetic field. இப்போ electric field மட்டும் தான் கொடுத்திருக்கோம், magnetic field கிடையாது. So let this is the screen. Now initially அது எப்படி போகும்? இப்படி போய் hit ஆகும். When electric field is applied, இந்த point வந்தது என்ன ஆகும்? It will be deviated from its path. It will go and hits here like this. So இங்க வரும்போது initial velocity, forget about the velocity here. When they enter into the metal plates, can you say what happens to its initial velocity? மறந்துருங்க, initial velocity 0. Initial adukku velocity 0. Within the metal plates we are going to see. When they enter, its initial velocity is 0. As time passes, its velocity slowly increases. Now let this be the deflection produced. இங்க வெளியே வரும்போது அந்த deflection என்ன எடுக்குனா y. So based on this, இதுக்கு proportional ஆன ஸ்பீட்ல எனக்கு deflection கிடைக்கும். First I will find out what is the deflection produced from at this point when they come out of the metal plates. Clear? Now initial velocity இருக்கு, அப்ப final velocity இருக்குமா? See here, what is the second equation of motion? S equal to ut plus half at square. Clear? Into the u into the initial velocity. What is t? Time taken for the electrons to travel this metal plates of length. Length enna sonna first? L irukku. V theriyum. Kandupidichitta. Can I find out t? T eppadi? Velocity formula enna? Distance traveled by time taken. How much distance these electrons are traveling within the metal plates? L என்ற தூரம் தான travel பண்ணுது இல்லையா? So distance is L by time taken. Now what is T? L by V. T தெரிஞ்சிருச்சா? Now A என்றது என்ன? Acceleration. By Newton's second law, what is force? Ma. From this, what is A? F by M. What is here F? Force due to what? நீ apply பண்றியா? நீ போய் தள்ளி விடுறியா? Force due to the electric field. That is given by? Very good. F equal to E by M. So I have calculated what is the acceleration. Just what is here? Yes. Displacement. How much is the displacement here? Let y be the displacement when they come out of the metal plates. This y will be directly proportional to the y1, which is nothing but the displacement produced on the screen. Screen la displacement adu. So s ku badala y eludalama. Substitute all this in this formula. What happens to that equation? Y equal to u in a 0. T, let it be as it is. In a 0 into anything is 0 plus of A is into T square L square by V square. So what happens? Y equal to this term vanishes. What is the remaining? E L square by 2m V square. Already we have calculated what is the velocity of the electrons. It is given by V equal to E by M. Substitute the value of V here. What happens? E L square by 2m E square V square numerator ku poiduma. 1 E gets cancelled. What is the remaining? E L square V square by 2me. What is this? Displacement when they come out of the metal plates. Now I already told this displacement will be directly proportional to the displacement produced in the screen. So I can write y is directly proportional to y1. If I remove this proportionality, if I have to introduce a constant. Let that constant be k. K y1. Now can I write this? Here y1, just change this and write. Can you write y1? The displacement produced at the screen. What is y1 here? This given by y1 equal to k. Y value is this one. EL square B square by 2me. So this one will be the displacement produced. From this, can I find out E by M? What for we are doing this experiment? To find out the charge per unit mass. What is E by M? Idha enakku venum. Take the other things that side. Just keep E by M. Take the other things that side. Enna agum? 2 y1 E by k L square B square. By this I can easily find out the charge per unit mass of the electrons. See what is y1 is the displacement produced by the electrons on the screen. By the displacement I can easily find out by using a scale. E is nothing but the electric field intensity. L is the length of the metal plates. That one you are going to select. So I can easily calculate that length of the metal plates. B, magnetic field strength. By substituting all the known values, I got the charge per unit mass of the electrons. K is a constant. That constant value depends upon the arrangement. Yeah, that they will give. So substituting all the values, I can easily find out the charge per unit mass. It's a 10 mark question. Very important question. Irukka, and the constant value matta underline pannuma. Then and there you please underline the constant values and the important values and all. Engenga data varudho underline panniko 1 mark use agum. Next, Millikan's oil drop experiment to find out the charge of an electron. So another important 10 mark question. See, in the 6th lesson 10 marks are very easy. This one Millikan's oil drop experiment konjam lengthy ah irukum. In the writing part nariya irukku. Diagram konjam kashtamā feel பண்ணுவீங்க, but it's very easy only if you write point by point. This is also another important 10 mark question. So using this Millikan's oil drop experiment, we are going to find out the charge of the electron, which is nothing but 1 by 6 into 10 power minus 19 coulomb. Using here, the principle what he used is, already we know the electrons, that is the cathode rays, will be deflected by electric and magnetic fields. Being by the deflection produced by the electric and magnetic fields only, he can able to find out the charge of the electron. He had a horizontal circular plates, two metal plates. At the top he had some hole. Through this only you are going to spray a highly viscous liquid. An oil drop. First we will see what happens when it is going to have a free fall. What is meant by free fall? Or oil drop, let it be a highly viscous liquid. Yeah, this oil drop I am going to spray in between the two metal plates. Yeah, it is allowed to move under the action of gravity alone. It is allowed to move or fall under the action of gravity alone. That we call it as a free fall. Then again I will apply some electric field. By applying the electric field, there will be a deflection produced. Ionize pannittu and the charged oil drop I can able to make it to move up or move down, or I can also make it to stand still within the two metal plates, and I can do several experiments or recordings also I can take. Values, repeated values also I can take. So what I am going to do, I am going to move see the motion of the oil drop under gravity, that is free fall, and I am also going to see the charged oil drop, how it is going to move in the electric field when an electric field is applied. First I will see the charge of the oil drop is going to move only under the action of gravity. That time I will find out what is the force acting. Then I will make it to be a charged particle. I will make it to become a charged oil drop by applying a beam of X-rays. So a beam of X-rays when the pass பண்ணும்போது it will ionize the gas. When the ionized gas, the oil drop will pick up on two electrons and it will become a charged oil drop. அந்த மாதிரி ஒரு charged oil drop electric field apply பண்ணிட்டு I can make it to move down or move up, or I can also make it to stand still for my observations. This is what we are going to do here. By doing this, I am going to find out the charge of an electron. E value கண்டுபிடிக்க போறோம். See, the ரெண்டு metal plates இருக்குமா, these two metal circular plates வந்து they are kept horizontal, exactly horizontal, using two insulating rods. இந்த ரெண்டு insulating rods just parallel வைக்கணும்ன்றதுக்காக சப்போர்ட்காக வச்சிருப்பாங்க. Here I have atomizer. Using this atomizer I am going to spray a oil drop. இதுதான் ஸ்ப்ரே பண்ண போறோம். என்ன ஸ்ப்ரே பண்ண போறோம்? Oil drops. Let it be highly viscous liquid like glycerin. Glycerin is a highly viscous liquid. The whole arrangement is kept inside a chamber which is going to maintain a constant temperature. The whole setup எதுல வச்சிருக்கோம்? Just it is kept inside a chamber. In the chamber kulla C into the chamber, it is having a dry air. It is having a dry air. This one is your constant temperature bath, which is going to maintain the temperature of this air. Temperature change aga poradilla. Here I have a source of light, so that it will eliminate the light. I can view the oil drops movement using a low power microscope. Here it is connected to an induction coil. This is going to produce a high potential difference. என்ன கொடுக்க போறோம்? ஒரு induction coil கலெக்ட் பண்ணிட்டோம். இத இந்த ரெண்டு metal plates A and B, it will produce a high potential difference. Here I will have a beam of X-ray so that I can make the air inside the metal plates to be ionized. This to begin with. What I am going to do first, I will spray some oil drops inside the two metal plates. என்ன பண்ண போறோம்? First இந்த atomizer யூஸ் பண்ணி press பண்ணதுமே இதில இருக்க highly viscous liquid வந்து ஒரு drop இங்க it is going to descend towards the gravity. Descending in a moving down. First, what happens when it is moving under the action of gravity? Motion under gravity. when it moves, see already in the last year 11th standard itself we are studying what is meant by viscous force and what is meant by terminal velocity. இல்லையா படிச்சிருக்கீங்களா இல்லையா 11th ல terminal velocity படிச்சிருக்கீங்க. what is meant by viscous force? what is meant by viscous force? இங்க ஒரு highly viscous liquid, it is moving inside the two metal plates. Here I have a dry air only. இப்படி மூவ் ஆகும்போது it will may experience some upward force. That upward force we call it as the viscous force. After some time when it attains a constant velocity, இது downward ஒரு force இழுக்குமா இல்லையா? அந்த oil drop எப்படி மூவ் ஆகுது? downward direction. So it will be having a downward force. The opposing force we call it as the viscous force. When these two forces become equal, it attains a constant velocity. That constant velocity we call it as the terminal velocity. So at a stage is reached when this oil drop attains a terminal velocity. Let that terminal velocity be V. Can you say what is the downward force acting on it? Downward force formula sollu. Newton second law. Force equal to m into a. Force equal to m into a. enna inga enna acceleration? Acceleration due to gravity. அப்ப என்ன எழுதுவோம்? m into g. F equal to m into g. Here what is mass? Mass of the oil drop. Mass formula enna? Volume into mass formula enna ma? Volume into density. Write this in your rough note. Let rho be the density of the oil drop. Rho என்றது என்ன? Density of the oil drop. G. Say here for our calculation purpose we will assume the shape of the sphere, shape of the oil drop to be sphere. Volume of a sphere? Volume 4 by 3 pi a cube. Volume of the sphere என்னமா? Pi a cube, where a is the radius of the oil drop. Rho g. Clear? So volume into mass volume into density into g. Force, this one is nothing but your downward force. இந்த force எப்படி act பண்ணுது? Nothing but the weight. சொல்லலாமா? Force it. Now what is the opposing force? என்னது அதுக்கு opposing force? Viscous force. How I got this viscous force? ஒரு ஆயில் டிராப்பா இப்ப மூவ் ஆகுது இல்லையம்மா, அந்த ஆயில் டிராப் இருக்கிற இடத்துல எது ஆக்குபை பண்ணியிருக்கோம் ஏர்லியரா? ஏர். ஸோ அந்த ஏரை வந்து டிஸ்பிளேஸ் பண்ணிட்டு இந்த ஆயில் டிராப் ஆக்குபை பண்ணிடுச்சு. ஸோ இந்த டிஸ்பிளேஸ்ட் ஏர் தான் உனக்கு அப்போர்டு ஃபோர்ஸா கொடுக்குது. இல்லையா? ஸோ ஐ வாண்ட் டு ஃபைண்ட் அவுட் வாட் இஸ் த ஃபோர்ஸ் due to this displaced air. That we call it as the viscous force. Can you say what is upward force acting now? Let sigma be the density of the air. Rho என்றது என்ன? Density of the oil drop. Sigma என்றது air. So அந்த air இருக்கிற இடத்துல போய் oil drop வந்ததுமே air displace ஆயிடுச்சா, அந்த displaced air என்ன பண்ணும்? It will oppose it. It will oppose its motion. So that we call it as the viscous force. Same formula. அப்ப இது எந்த டைரக்ஷன்ல? downward force வந்து இதுக்கு oil dropக்கு, upward force வந்து viscous force. So same formula you are getting. Force equal to mass into acceleration. Upward force equal to F equal to m into g. It is against acceleration due to gravity. Clear? M volume. Sphere தான், அது sphere ஆ இருக்கும்போது displaced யாரோ sphere தான். G the acceleration due to gravity. Force only. Say volume 4 by 3 pi a cube sigma g. This will be the upward force. Clear? Now I want to find out what is the net force. How the oil drop is moving? Is it moving down or up? Down. இல்லையா? அப்ப net upward force வருமா, net downward force வருமா? ரெண்டு force ஆக்ட் பண்ணுது ஒரு oil drop மேல. ஒரு force வந்து கீழ் நோக்கி போகுது, இன்னொரு force அதை oppose பண்ணுது. இல்லையா? அப்ப எந்த force greater இருக்கு? எப்படி கண்டுபிடிப்ப? கீழ் நோக்கி தான அது போகுது. அப்ப இந்த force தான greater magnitude இருக்கு than the upward force. Since the oil drop is moving under the action of gravity, the force due to gravity is greater than the upward force. How to find out the net downward force now? One force minus another force. It is given by net downward force equal to. அப்ப இது தான greater? This minus this. எது காமனா இருக்கு வெளிய எடுத்துலாமா? 4 by 3 pi a cube rho minus sigma into g. So this will be the net downward force acting on this oil drop when it is descending under gravity. When this force is equal to the viscous force, the object attains terminal velocity. எப்ப அதுக்கு terminal velocity என்றது constant velocity. Clear? So அதுக்கு எப்ப constant velocity வருதோ, this net downward force will be equal to its viscous force. And the viscous force formula என்ன? Stokes law படிச்சிருக்கீங்களா? 6 pi neta AV. What is your neta AV? What is this V here? Terminal velocity, constant velocity. So அப்ப இந்த net downward force இந்த viscous force equal இருக்குமா? அதுக்கு terminal velocity கிடைக்கும்போது equate these two. 4 by 3 pi a cube rho minus sigma into g is equal to 6 pi neta AV. இதுல இந்த can you find out what is A? That is the radius of the oil drop. Write this equation and you please find out what is the radius of the oil drop A. Pi a cube rho minus sigma into g equal to 6 pi neta AV. எது cancel பண்ணலாம்? 4 pi pi 1a gets cancelled. Then what is the remaining? Let it be. Just write remaining. What are the remaining things? 4 by 3 pi a square rho minus sigma into g 6 neta v. Clear? I want only a square. Take all the things on that side. What is a square? இங்க 6 neta v இருக்கா? இது அப்படி போச்சுன்னா என்ன ஆகும்? Into 3 by 4 இங்க rho minus sigma into g. இதை further simplify பண்ணலாமா? 2, 3. So what is the remaining? 9 neta v by 2 into rho minus sigma into g. What is this? Radius of the oil drop. A equal to 9 neta v by 2 into rho minus sigma. I have to take the square root of this. So square root இப்படி எழுதலாமா? Power whole power 1 by 2. So what is this A? Nothing but the radius of the oil drop. Take down. So this and all we have seen. We have calculated the radius of the oil drop under the motion of gravity or when the oil drop is having a free fall motion. Now I am going to apply or send a beam of X-rays through here between the metal plates. என்ன பண்ண போறோம்? ஒரு beam of X-rays pass பண்ணும்போது what happens to the air inside the two metal plates? It gets ionized. Positive negative divide ஆயிட்டு this oil drop will pick up 1 or 2 electrons from this air and it will become a charged particle. இது என்ன ஆயிடுச்சுப்பா? ஒரு charged oil drop ஆயிடுச்சு. Now I apply electric field so that this charged oil drop is going to move up. எப்படி மூவ் ஆகுது? It is going to move up because of the electric field applied. One thing, X-rays pass பண்ணியாச்சு, I make it as a charged oil particle. In the charged oil particle, it is not going to move down. It is going to move in the upward direction by the applied electric field. So, அந்த downward force விட நீ என்ன பண்ணணும்? அந்த net downward force ஒன்று இருக்குல்ல அந்த oil drop-க்கு அதை விட greater-ஆன electric force கொடுத்தாதான் அது மேலே போகும் இல்லையா? Isn't it? Otherwise, equal-ஆ கொடுத்தீங்கன்னா அப்படியே நிற்கும். Net downward force, equal amount of electric force கொடுத்தனா it will stand still. Now I want to make the oil drop to move in the upward direction. So I want to give a force which is having a greater magnitude than the net downward force. Net downward force விட அதிகமா கொடுக்க போறேன். Now I want to find out what is the electric force. Electric force formula இப்பதானே பார்த்தோம். What is? Can you say what is the force due to the electric field? E into E. Electric field strength into E. Here Q into the electron சொல்ல முடியாது. Let it be charged oil particle ஆல let it be EQ. This one is your upward force acting. இது என்னது? Upward force acting. Already we have calculated what is the net downward force. It is given by 4 by 3 pi a cube rho minus sigma. இப்போ இது ரெண்டு force act பண்ணுது அந்த charged oil drop மேல. ஒரு force என்ன? மேல upward force. One net downward force அவ்வளவு இருக்கு. அப்ப எது greater-ஆ இருக்கு இதுல? அது மேல இருந்தோன்னா மூவ் ஆகுதுமா oil drop. அப்ப this force due to the electric field will be greater than the net downward force. That is why the oil drop is moving upward. So how to find out the net upward force? One force minus another force. Since the oil drop is moving up, this force will be greater. So net upward force equal to EQ minus 4 by 3 pi AQ rho minus sigma into G. இப்போ net upward force கண்டுபிடிச்சு. When this force is equal to the viscous force, now the object attains a constant velocity. That terminal velocity, let it be V1. What is V1? The terminal velocity attained by the charged oil drop. So just equate this with the viscous force. Now the viscous force is 6 pi neta A V1. Where V1 is the terminal velocity for this charged oil drop. Already அங்க ஒரு equation போட்டிருக்குமா? இங்க the 4 by 3 pi A cube rho minus sigma into G equal to 6 pi neta A V போட்டிருக்கோம். Let this be as equation 1 and let this be as equation 2. Add equation 1 and 2. Add these two equation. What you will be getting? இது அதுவும் cancel ஆயிடுமா? இது ஒரு positive, அங்க positive, இது negative. So it gets cancelled. What is the remaining? இது என்ன இருக்கு சொல்லு? EQ equal to 6 pi constant என்னமா இருக்கு? காமனா இருக்கதா வெளிய எடுத்துலாமா? 6 pi neta A V plus V1. What are it may? V1 plus V or V plus V. Both are same. Clear? So EQ. What we are going to do here? என்ன கண்டுபிடிக்க போறோம்? Charge of the electron. Clear? What is here E? Q. Charge of this oil drop. இது தான கண்டுபிடிக்கிறோம். Charge of the electron கண்டுபிடிக்கணும். E என்றது electric field strength. இது எப்படி கண்டுபிடிக்கிறது? The terminal velocity this and all I can easily find out using a microscope. அந்த observation வச்சு I can easily find out the terminal velocity, radius of the oil drop கண்டுபிடிச்சிட்டோம். Neta coefficient of viscosity of the highly viscous liquid glycerin க்கு. That is also given. Pi number, 6 number. E எப்படி கண்டுபிடிக்கிறது? Here I am applying a potential to the metal plates. Clear? I know what is the distance between the two metal plates. Distance தெரிஞ்சிரும். ஏன்னா நீ தான arrangement கொடுக்குறோம். நம்ம தான் செட் பண்றோம் arrangementலாம். So I know the distance between the two metal plates D. I know the potential what I am applying. If I know these two values, can I find out E? What is E then? First lesson படிச்சோமே. E equal to V by D. So by knowing these two values, I can find out the electric field E equal to V by D. Q equal to another charge of the oil drop. If I know all these values, I can find out the charge of the oil drop. Q equal to NE in படிச்சிருக்கோம் ஞாபகம் இருக்கா? What is NE? Number of electrons. E into the charge of. So by this, he calculated the charge of the electron to be an integral multiple of least value. Or the greatest common factor that he got it as E equal to 1.6 into 10 power minus 19 coulomb. He did for so many charged oil drops and at last he came to the conclusion all the charges will be having a அதோட எல்லாத்தோட greatest common factor எடுத்தா he got this value of E to be 1.6 into 10 power minus 19 coulomb. So it's a very simple experiment. And the diagram போடணும், and the introduction partலாம் எழுதணுமா, description of the apparatus, this and all you can write it on your own words provided if you are thorough with the diagram. The diagram thorough பண்ணிட்டு important key points values எல்லாம் underline பண்ணிட்டு by heart பண்ணிக்கோ.